So, there is an upside.
Your train room must be in the house and air conditioned.
It's a separate building, Gary.
But it's air conditioned.
You better believe it.
Yeah.
There's nothing out here that's not air conditioned.
Well, my train room is a garage and it's not air conditioned.
Oh, I'm sorry to hear that.
So, and I can't start early in the morning because she's not awake yet.
Aha.
I can't make any noise.
No. As you'll see in my presentation, I put a building on my property. It was originally for my mother. She wanted to move from New Jersey out here so that, you know, she could be closer to family. And she came out here and a realtor said, let me show you Sun City. And I had the building already built. And I said, what am I going to do with that building?
Oh, yeah.
All right.
Hey, Ryan.
I'm going to,
Hey, Ryan.
hey there.
Ryan, you just ended the best San Diego division meeting ever.
Thank you. Thank you.
You're welcome.
Yes. I'm going to call us to order. I'm going to call us to order because I finally figured myself out. We are live on YouTube at this point.
Oh.
Hey there, I'm going to mute everybody and get us started. Oh, thank you. Thank you. I appreciate that. I'm glad you guys are having a good time talking because I was having a hard time on my end. Thank you. All right, so we're going to hold on. I don't know why I'm getting feedback. Oh dear. Wow, that's really rough. Okay. I missed my window to close and I was getting myself in because we're on a lag on YouTube. I don't know if you guys heard everything getting repeated. So I couldn't find the window. I closed it. I'm ready to go. All right. Well, let's just begin then. We have a show and tell. We have two show and tell people today. And then our layout tour by Frank Baker of Morristown Erie Railway and our clinic by Tim Foote, Electrical Basics for Model Railroaders. So I am going to turn it over to Trudy right now.
All right, can you hear me? Are you ready? Can you hear me? Hello?
We can hear you. We can hear you. I can
Oh,
hear
good.
you.
Then I can
Yes.
share screen now.
Yes, you can.
Is that good?
Looks good.
Or are we good?
We are good. You may proceed.
Okie doke. I'm Trudy Seeley, and I belong to the San Diego Model Railroad Association, and we have a layout at the museum in Balboa Park. Our club has an O scale, the Cabrillo Southwestern, where I work, and an HO layout, the San Diego and Arizona Eastern. On our O scale layout, they had this cardboard mock-up of an engine house for years and years, and they asked if I would build something to put there. I didn't want to go with straight scratch build because I thought it would take forever, and I'm not great at math, and there's all the rafters and stuff to figure out. So I found a kit, but it was pretty, well, kind of a boring kit. Didn't have a lot to go with it. Didn't come with the roofing, and that was all there was for directions. So the first thing I had to do, because the tracks were hand laid where I'm going to be putting this, I couldn't move the tracks. So I had to split the building and make it a little bit wider so that the tracks would fit in the doors. I didn't bother butting them up because you wouldn't be able to see either end by the time I got done. So the first challenge was making tons and tons of little boards because it came with scribed siding, and that's not really very good for O scale or for the a building right up next to the viewing window. So I just bought northeastern scale lumber and then some western scale lumber, and did a lot of, this is a flea comb here for my dog, and that works, as well as saw blades also work. A little bit of sanding afterwards. I used 2 different Minwax stains on it, and I also used AI, alcohol and India ink. So there's wood, the stuff in process. This is what the pieces of scribe siding look like. So the inside would not have had any siding. I mean, it wouldn't have looked like boards on the inside, but it did have the notches where the rafters go. So that was helpful. And as I prepared boards, I would just lay them out on top of the framework so I could see how many boards I needed. The nail holes I made with a little compass, an old metal compass, and then touched it with a black ink pen and smeared it with my finger. The bottom is chewed up with an X-Acto knife and then dipped in the AI solution to darken and dirty it up. There was no inside anticipated, so I had to build an inside. But see, you can see how you have boards on the inside if you use board on board. You've actually got boards. And the shading and the dirt that accumulates here is mostly chalks with a little alcohol. And the signs are just paper signs that I printed and sand the back down. And these were just various O-scale things that I picked up. So there's a picture of the windows in. They were Tichy windows that came with it. And I'm almost ready to go there. Here's the nasty part. This was the part that I was afraid I couldn't figure out, which I had a pretty hard time with it. Obviously, once I split the building, it wasn't wide enough. So these rafters were not long enough. So I had to put boards on the top so that they would, you know, go in those notches. And then I had to raise it up. And then I had to raise the cupola one up. And I kept fiddling with it until I finally got all these crazy rafters, and they were going to go up on the, and they would fit in the little holes. The next problem was the kit wasn't meant to have the top removable because there's no bottom. So you've just got 4 walls hitched together. This blue tape, painter's tape, is because I had to put another piece on to make the roof longer. Everything, there was a lot of stuff held together with the painter's tape. And then what I did was I put little alligator clips on each side of each little rafter tail there, and up on top too. And then I was able to turn it over and glue the rafters in onto the roof and then put it back on. So to make it a little sturdier, I put corner braces on it, and I put a board across the middle, which also allowed me to hang my little shop lights. There's also these big heavy ones. There's also a little LED strip in there just to make sure we have enough light. Then I moved on to the roof, and I wasn't sure what to use for shingles. I wanted to try wood shingles. So I got a hold of Kevin Spady, who just makes awesome ON30 models. And I sent him a few that I'd found, or a few names, and he said, yeah, he had used builders and scale. So I ordered those. They come in sheets. They're only this long, but the sheets are wider, and you have to, you know, color them and stuff. But I just use craft paints for this part and some chalks. And I was about a quarter of the way through when I realized that I had enough for half the roof, because I just really hate math. And I figured it all out and did 1/2 the roof. So I had to order it again and try to color them the same because I'd already colored the first batch. Anyway, there we are, sort of finished. I just put some junk on the outside. I needed to weather the roof just a little more. So I did some streaking from some stuff, and I did AI again, alcohol and India ink again, to dull the roof down a little bit. And then I painted up some stuff to put on the outside. And that's it. Any questions?
I'm going to comment that if you're watching on YouTube, that the chat is now live. So if you can't see it, you can refresh your screen. No questions.
Well, everyone's muted, Ryan.
Well, can people unmute? You should be able to unmute yourself.
Yes,
Oh.
I think we can mute.
Yeah.
Okay, if you have any
Yeah.
questions,
Yeah.
please unmute yourself.
Or you
I
can type
just want to say great job.
Likewise. Very nice, Trudy.
Thank you.
Very nice. How long did you build it, Trudy?
Well, actually, I worked on it for a few months because when I would get to a hard part, I couldn't figure out, I would just all of a sudden be busy with other things. I have a real problem that way. When I get stuck on something and I don't know what to do. And this one was just challenging. Trying to figure out that roof and the rafters was kind of head scratching.
So now, Trudy, when you make those models, are they, when you put it on a display, do you glue all the sides and the roof together, or is it all, can you take it all apart? How does that work too?
No, it was important that I didn't glue the roof on. The roof is supposed to just set on it so that we can do maintenance, we can replace the lights. For something that runs as much as it does at the museum, because it's on all the time, the lights and stuff. So it's a little different. There's a lot more maintenance than on a home layout that isn't run 24/7. Well, not that it's 24/7, but it's run a lot. So it will just set on top, so it can be removed.
Wow.
And then the roof will set on top of the building.
The detail is unbelievable. It's just incredible.
Thank you.
Tracy, is it on the museum layout now?
No, we are having a challenge with leaking toilets above the O-scale layout.
Oh,
No
no.
kidding. No kidding. The rails
Oh
were,
my
I went
God.
into work for the first time just this well, I worked on Memorial Day, and the rails were, I couldn't run the narrow gauge part at all. The rails were rusty where the water had dripped on it. So
Oh
I'm not
my
going to take it
gosh.
in and hook up all the lights and stuff until we get that fixed.
Smart.
Oh my gosh. And in your previous, initial clinics on this, I had mentioned maybe submitting this for, I don't know, AP certification or something. Have you considered that anymore?
Well, I think they can't do it with the video. They have to actually do it live. And with COVID,
I mean,
we're not going
At
anywhere.
some point. I mean, at some
Yeah.
point in the future.
Yeah, I would sometime.
Good. That's what I want to hear.
Very nice.
Okay. Thank you, Trudy. Thank you very much. No other last questions for Trudy?
Well, okay, let me ask another question because
All right, ask your question, Mike, and then start your presentation.
okay, because there's so much detail. So basically, Trudy, you scratch built every single board on that building. Is that correct? Like
Yep,
you
the
built-
board on board. It's tedious and it takes a long time, but gosh, it really looks good when you're done. The board on board, one board at a time, really. And it's not difficult, it's just tedious.
It's just amazing. I mean, you built that building from scratch, like you're a contractor.
No, I didn't do the framing. I was trying so hard to avoid doing the framing.
Oh.
So that was the one thing I was able to use, even though the rafters didn't work out very well. The side frames worked very well.
Wow, that's just amazing.
Kit bashing is fun.
Yeah. Okay. So
You're up, Mike.
I'm next. Okay, so let
Yeah.
me see if I can share my screen. Okay, I'm just waiting for my computer here. Let's see what's going on here. Oh, there we go. Okay, so everybody can see, I think. And
We can
so
see you.
just so you know, I started in the model railroad hobby about a year ago. And my first trip was to Reed's Hobby Shop. And the reason why I have this picture is they had a test track So if you buy a locomotive, they can put it on the track. And at the time, I didn't know what it was for, but they could put the locomotive on the track and then show you that the locomotive works. And so whenever I first saw that test track, I just thought that was amazing. I never even knew people did that. So when I first started, about a year ago, I learned about DCC and sound. And again, I was amazed. I had no idea they had been putting in computers and locomotives for years. So one of the first things I did, I decided I'm going to make myself, I scale in HO scale. And I decided I would go ahead and make a model workbench for the hobby.
Hey, Mike, do you want to make one of your pictures bigger as you talk about them? We see a group.
Okay. Is that better or no? No. What? Okay. What am I doing wrong? Is that better? Oh, take this off.
I think if you double click on the picture, it'll open the picture viewer, correct?
I have the picture viewer open. Oh, you don't see that?
We see we see about 6 or 9 photos at once.
We see Windows Explorer, your file Explorer.
Yeah.
I have a picture open. All right, let me try again here.
You might want to choose, if you don't, make sure you don't have anything on your desktop that you don't want us to see, but if you share your desktop, you can move around between different things. Probably you only chose the Explorer, so we couldn't see the individual picture. I don't know. Just a guess.
All right, let me try this again. Thanks for letting me know. Let's see. Oh, here we go. Okay, there. Can you see that now? No.
Yes.
Okay, this is the Reed's Hobby Shop.
Yep.
And so here's their test track where they have several. I think they have an N scale track and an HO scale track. And like I said before, I'm brand new to the hobby about a year ago, and I was amazed that they even had this and that someone even thought to do this. So my first task I thought would be to make a HO scale model workbench. So my workbench is in a hallway, and my workbench is over 4 feet wide. And so I thought, well, I'll just make a DCC and sound programming track with a double main line and start with that. And then I realized, well, my programming track is on my workbench and that takes workspace away. So then I decided I'm going to go ahead and put the programming track on the wall. And I have a non-powered track at the back of my workbench just to hold rolling stock. That's right here in the back. And in fact, this non-powered track is actually attached to the wall and is above my workbench. So if I move my workbench, I don't move any of the rolling stock because that's actually a shelf on the wall just less than a half an inch above the workbench. So then I knew so it turns out the wall's about 6 feet 5 inches and it's longer than my workbench. So I thought I'm going to go ahead and create a longer programming track to take advantage of the entire wall. So this was my first start at getting that programming track off the workbench. And there's the wood for the new programming track. And also when I started in the hobby, Reed's Hobby Shop recommended that I use the NCE Power Cab, and they recommended it because several model railroad clubs here in San Diego use that that cab. So if I would join any of the clubs, I would have a cab that was compatible with several of the clubs. So that's why I went ahead and bought the NCE Power Cab, and I do like using it. So then here's a picture of my short programming track and my longer piece of wood for my new programming track. And again, like I said, it's just being in the hobby has just been so much fun for me. Every little thing I do is just a pleasure. It's just so much fun. It takes a lot of work, but it's just I'm just having a blast. So this picture, I'm just trying to figure out the correct width of the tracks on the board by putting some rolling stock on there and making sure I can put my fingers between the rolling stock.
1 minute warning, Mike.
Okay.
Thank you.
And this is just working more on the programming track, working more on the new programming track, getting the programming track done. And it's now done. And then I made a little prototype. I wanted to have a little place to put my NCE Power Cab power module. So this is the programming track installed. And again, this little piece of wood that I made here is a prototype. I'm going to change that later. I want to use not only an NCE Power Cab on my programming track, but a regular DC transformer so that I can test either type of locomotive and the electronics. So this is that prototype is a work in progress. And that is my finished DCC and sound programming track with a turnout. And then one last graphic. So my current programming track is from where my mouse is showing to the left. I have a doorway here, which I'm going to make a bridge. So the hallway is a total of 11 feet. The programming track is 6 feet. And then I'm going to have, so I'll have a permanent track on the right of the doorway and then a bridge in front of the doorway. So then I'll have not only a programming track, but also a mini switching track. So I can use it while I'm making my layout. So at least I can have some fun because while I make my layout, because I think the layout is going to take a couple years from now to get that going.
How long is your hallway all told?
Yeah, so the hallway is 11 feet 6 inches. And
that would be a great switching layout.
yeah, so I might have a couple more switches down like on the bridge or on the other side. I'm not sure yet. But yeah,
and if you want the N scale, you can have twice as much.
I know, N scale. But yeah, so I'm just having a blast, and so yeah, that's about it. I don't think there's anything.
Any other comments or questions for Mike before we move on to Frank?
Good start.
Was it?
Yeah.
Was that a 2x6 or
Looks
2x8 you used for the base?
Yeah, it's it's a 2x6. Yes.
Okay. Very nice.
Yeah, I kind of the board was a little thicker than I should have had, but anyway, it was very affordable. So that's why I chose it.
Looks cool.
Price was right. Yeah, or any suggestions are welcome, but yeah.
Looks good.
It's been lots of fun. Lots of fun.
All right. Thank you, Mike. Very good. I want to introduce Frank Baker. He is going to be doing our layout tour. Frank is in Arizona. If you don't know him, he's a division director for the Arizona division and an awesome modeler. So I'm going to pass it to him. Frank, you are Up.
Okay, now you're gonna have to guide me to what you,
You got it. You have your PowerPoint open, I take it.
I do.
Okay.
Click on it
So-
like that.
So,
Can you see it?
no, I can't see it yet.
Share it. I
Go
have to
into Zoom and share.
Yeah, share screen.
There you go. See, it's all coming back.
Yeah, it's
Find your PowerPoint.
now can
Look
you
at
see
that.
it? Now you can see it.
I think you did that even faster than you did that earlier this week. All right.
Looks good.
Yes,
Okay.
go ahead and do your slideshow
Okay.
menu to start your slideshow, and you are in
All
good
right,
shape.
very good. All right, as my name's Frank Baker. As Ryan said, I've been in this hobby since I was about 6. I'm a lot older now. The layout you see behind you is about 30 years old. I'll tell you a little bit of story about that. The railroad there is a Morristown area railroad. It was a little short line that ran from Morristown to Essex Fells. It never made, it was supposed to span between the Erie to the Lackawanna. It didn't happen, but it was around for a long, it still is around, but it's not in really good shape. I just picked a name because I grew up around it, and so be it. And I'm originally from New Jersey. I left in '63 and I have no intentions of going back. I have traveled, I've lived a lot of places, so you'll find a lot of influence from New England in here. Some of that is because of the kits that I've purchased. Some of it's because the buildings that I've modeled or scratch built, as you'll see later on.
Frank, do you want to go full screen?
Yeah, how we do that?
Look at the top, find your slideshow. It goes File, Home, Insert, Draw, Design, Animation, Slideshow. Across the top,
Gotcha.
click Slideshow. There
Yep.
you go. And then from the beginning, all the way on the left from beginning.
From the beginning, okay.
You're on
Thank
it. Good job.
you. Okay, look at that. Okay. As I mentioned, and I'm going to backtrack a little bit, but let me tell you about the layout is a double dog bound, as you'll see in the next slide. It's code 70 track. I just love the appearance that you get with code 70. It looks real. I've seen code 83. Code 100 is a little bit intense for me, but 70, when you do super elevation like I have, it really photographs extremely well. I'm about 400 feet of a mainline track. I've got almost 300 buildings on the railroad. I keep saying, my wife, I'm not done yet, and I get this stink eye. Every once in a while, we get the downsizing routine, you know. You're too old, we had to move, you know, you're not keeping up with all the yard work. It goes on and on. Okay, so here is a couple of drawings. The layout was in Great Model Railroads last year. The layout itself is 18 feet by 33.5 feet. Now my control system, well, I started with an old analog system, which was onboard before. I don't know whether even Pete knows about onboard, but I have lens, and I've had it for 30 some years, and it works very, very well. And the lens is the granddaddy of DCC. Layout height is 43 to 53. It's freelance layout. I've got about 400 feet of mainline track. And when I say structures, it's 250, 275, somewhere's in there currently. It's a double dog bone. The railroad starts and ends where the cursor is at the top of the layout plan. Where the cursor is one end of the dog bone, and then the other one is above that by about 2 inches. It takes about a half an hour to go at slow speed down, and there's a lot of hidden track. It's a dual main line from where the cursor is out through East and West Orange, comes all the way around, and at Chester it splits, and one goes in the dark. And where can you see where my cursor is? It's on B, and it goes from there all the way back to the top of the screen, and it follows the same track plan you see up above. You can see a schematic that I've put over there on the side. I've stretched it out, if you will. As I mentioned to Gary, we bought this house 30 years ago, and I was going to build a guest house for my mother. I built the house, and then she decided she didn't want to come here. She moved to Sun City instead. I said, oh, well, it's too bad, Mom. So I have myself a nice room. It's fully air conditioned. It's got its own heating and air conditioning, its own bathroom. It's a very nice facility. I made 2 layout designs. One was the one that I went with, and the other one was around the room, but it required a duck under. And I did not like the duck under. I'm getting too old for that. I'm too big and too, uncomfortable. So that's why all these little ins and outs around the room. Lower left-hand photograph, I build the bench work, and then I take cardboard to make the templates for all the curves and radiuses and all the shapes. And then I use those templates to cut the plywood. It's quick, it's easy, and it's relatively inexpensive. The lower right picture is just some early part of the bench work being, framed in. It's changed a lot. So what I'm going to do now is to take you through some of the towns along the way. As you can see, there's a bunch of them on here. Most of these are towns that would be back east in all close proximity. Great Notch is a small little town. It is hidden back in the corner of the room. It has a station and a water tower, and that is it, okay? There is actually a cabin up on the hillside, which a guy drives down to the station, but that's the extent, you have to, my layout, you have to walk around to see things. You just can't walk in and say, aha, there's a lot there to see. That's a combination, that building has, most of my structure has been modified. That's an fine scale miniature water tower in the back. I think the building was, I can't remember the manufacturer, honestly, at this point. This is Chester. And it's where the railroad goes from dual main line and splits. You'll see scratch-built buildings like this, and I'll show them more to you later on. And you'll see other high-end kits that I have. And then I've got some plastic, buildings in the back in here for around the city area. And so I'll go to Chester, we'll go to Little Falls, and there's a couple of photographs here of Little Falls only because it's difficult to photograph if you just walk in. South River Model Works Structures. This is the guy up in Canada, Dario Ladonda kits, also very nice to have. The water flows out of the Spencer box into a holding pond, and it comes down sort of greenish color into the river, moves from there. This is another view of it. The tracks to the right are the dual main line coming into or out of Chester, which is up on the back on your left, going into Ironia on your lower right. There's a scratch-built bridge here. There's some sound effects of running water. There's cabins, there's a tower, and there's a building here, which I'll explain later, which is my first scratch-built structure. This is Ironia, and the building on the upper right is a station, and I'll get into the detail on that later. Long buildings are very, very interesting to have to build, and I'll show you a couple that I've done and the problems that ensue. Again, more water, and it's signaled throughout. Another overview looking back a little bit farther. So you see Little Falls in the center. You see a little bit more of Ironia with a mine here. I think there's another shot here, another view of the mine. Now it's coming around to Essex Falls on your right-hand side. Again, dual main line, all super elevated track. This is a kit from George Barrett in Maine. I don't know whether everybody's ever seen one or built one. I started it. I didn't like his construction information. It was very elaborate and a little bit on the difficult side, kind of intense. So I started over again and I built everything from scratch. And I think it turned out better than his kit, but it's a nice, George is a nice guy. All right. Don't get me wrong. This is Essex Falls. There's a station there. There's a track over here where the cursor is that comes in. It's a bypass track from the track down in East Orange. It bypasses freight through the passenger station. South River kits. This is an old Campbell kit with the cows. My wife keeps telling me, she said, well, you need some water for the cows. I said, sweetie, they're going into the slaughterhouse and then go on the reefer. Okay, now I'm coming. So everything you've seen up to this point is pretty much, when I say done, 99% done. I keep adding little nuances here and there. To the right, you can see the beginnings of a blast furnace and some roads and some buildings in the background. The sky is one of those cardboard cutout sky pieces that you rattle can and spray it. And then I pulled down some more color down here to give the effect of water. Whoops, sorry, here. Okay, here's looking actually across the island. There's a walkway you can see from that green piece in front of you. So there's a blast furnace that is a little farther along than this. This is pretty far along, but there's, and some of the structures are in there. And then of course, this is on another island, the Army Navy store. And the street lights, they all turn automatically. This is just to show you the backdrop. I have 1, 2, 3 sets of track back in here that are hidden. So all of the scenery from the track you see in the foreground back behind there has to be lift out. So they're in 3-foot sections, and I can lift them out to get, if I have a problem. I will, not that I want to, but if I have to. Okay, and then you can see again the clouds, the sky, and this is the built up of one of those paper cutouts of a steel mill complex in here. This is a Walters steel mill kit that's been modified. It's longer. A lot of the pieces that you see here with the, like the U.S. steel on it, all the walls are not the supplied with Walters. I found a hobby shop in Houston that has a very thin paper with aluminum pigment on it that is wonderful. It's a little oversized, but it works for the steel mill, and it's thin. If you use the Walters stuff, it comes out to about a 1 foot thick piece of plastic, in scale. And then they're going, no, that's not good. So this is very, very thin. It's removable. The one that's not painted is removable. It's painted now. So you can see inside, because that's the inside of it. It's red clay that gives you the impression of molten metal being moved down through the canals. The lights that are in front of you, the red ones, they actually blink off and on and so forth. Let's see, where are we? Okay, so now we're into area under construction. There will be a open hearth furnace in this area. There is a rolling mill in the back side on the right-hand side. There'll be more buildings up above that track all the way around. Okay, now we come a little bit farther around. Now you're seeing Edison to the lower left, and the dual track up above is actually West Orange. This is fairly current. I've been building the buildings in the background here. Some are city classics. Most of them are in fact city classics back in here. And there's a couple of DPMs and so forth. This is a Bachman. But I put this highway that runs through the town, through the yellow building, continues off to the right, and then it hits another intersection. Then of course we have the bridge to nowhere here where the bus is. All right. And there's a lot of scenery in that area going on as well. A little farther back, you can see the ABBA lash up that's going through Edison, and then a 3 lash up Jeep scenario coming through West Orange. And on the opposite side of that part of the island, there's a trolley line that runs from here. It's just your point-to-point trolley line. And I still have to finish the spur that's underneath there. So then I can put this in and wire it. But the structure is done. I have to wire the station. Let's see there. I have to wire this guy here. You can see the interior in here. There's it's complete interior on the inside, and I have to light around. Okay, scratch build. Those that know me know I like to scratch build, and I've done a few. This is my first one. This was probably, I don't know, 35, 40 years ago. And when we had the open house for our last convention, somebody walked over and he said, "Where did you find all that lettering?" I told him, I said, I found it at the end of my paintbrush. I can't do it now, but I could do it then. This is Yakima Apples. I saw this building at a hobby shop in Florida. An NMRA modeler made this in a big module, and no prints. There were no plans or anything else. I took photographs of it, came back. I made 2 models, one for myself and one for a friend of mine in Florida that has done some painting for on my brass. I took this to the narrow gauge convention. Didn't get anything, but it's okay. I had fun. I made 2 of these. This is the Chester Station. This is actually a station in Fort Edwards, New York. I saw this in a painting book that I have by Randolph By. He did a lot of back east stations and other railroad buildings, and I thought it was very, very unique. So this is the second one I built, and it's got lighting on the inside. I have to give my wife credit for all the people. Years and years ago, well, maybe 39 years ago, we were at a national convention, and she said, "Oh, I want to help you with the hobby." And I said, "Sweet, okay. I'll tell you what, I can buy you some people, and you can paint people." Well, all those pricer figures, like they're 100 or 150 in a box. I bought her 18 boxes. Painting. She's still painting. This is East End Market. The photograph in the upper left-hand corner, a friend of mine posted that on a forum. The building is situated in St. Johnsbury, Vermont. And I said, that is very, very interesting. So he took a lot of photographs. He had one of those devices for measuring the building on the outside. And it told me the height of the clapboard siding. And from there on, I made everything. And I took Best of Show in this model at one of the events. I don't can't tell you which one, but that was a fun build. I will tell you, I had a small incident. I dropped it once. I was almost done and I dropped it. And the porch that you see in the lower photograph above the double doors, part of it fell off. But surprisingly, everything else was fine. And I put it back together and it still sits on the railroad. Still looks great. Now, that is a long structure. This is another long structure. This is the first one I built when I say of long structures. This is the station in Thurman, West Virginia, and I just thought it was very unique. It was in one of the train magazine years ago, and it was in my library of things to build. But long structures have a tendency to want to bow. And so I was almost done. And if you look at the lower photograph, you can see it stands off about 1/4 of an inch from the surface on the bottom. That's not good. So I put it on a piece of plywood, a lot of super glue and Elmer's glue, and clamped it down. And it's been there for the last 12 years or more. The interesting part of this is all those little stinking 2x2 scale lump pieces. Trudy, you're going to love this one. All those little pieces of lumber on the back porch there. Oh, not fun. Not fun. Another scratch built building. This is Duffy's Tire. The roof is completely trussed like you would do a building roof. And it comes off and it exposes the inside of the working area and the tire department. And then in the lower right-hand picture, you see a little tiny room there, and there's actually a sink, a toilet with somebody on it, a girly picture, and a light on the wall. So I get carried away a little bit, but it's fun. This is a tower that's in Illinois, but I call it West Orange Tower only because it was on my railroad. I make a lot of sketches up to show you how many components are required to put into that building. And so you see, here's one with the tower. The other one is the exterior details with all the railings and steps and so forth. And I think the outhouse is probably on there as well. This was a relatively quick build. In fact, a friend of mine made it into a kit. And that's a different story, but anyhow, it's fun, And the other thing you'll notice, if you look at the photograph on the lower left, the outhouse, I am known for my birds. Many of my structures have pigeons. And a friend of mine called me up one time. I'm on a forum, and he said, "Frank, you need bird poop." And so a lot of my structures, you'll see the bird and the bird poop. Wayne Weslowski lives in Tucson. He also was a teacher in Chicago area, Weslowski, I think it is. In 1951, I believe, he had this foundry in Railroad Model Craftsman. I had the article and I made two, one for myself and one for my neighbor down the street. And I build a lot of my structures on pieces of foam and then I integrate it into the layout. It's just an easy way to A, put it in, B, take it out, okay? There it is in the layout. Oh, some more structures in here. I just put some names down. The Delabar Woolens is a Bob Van Gelder, South River Model Works. I added the wing to the right. And it's one more floor in the entire wing. I added that. The little building where the Rainbow Beverages sign is on the building, that was same as the top of this building, but I just made a second one down in here. And if you notice down here in the lower right-hand corner, there's a guy on the tower and he's painting rainbow. The devil's in the details, okay? And you'll see all the telephone lines, electrical lines running everywhere. Another nice kit. This is by a guy up in Canada, Dario Ladonda. I have a couple of them. This is one. It's a cast resin furniture store. Very well, just a nice kit. And if you'll notice, the bus has it. You can't see it really well, but the brake lights are on the bus and the traffic signal is red. This is more of Rainbow Beverages. Again, a module, just a big bunch of pieces. There it is again. And I just plop it in. There's another building of which is on the layout. Okay, this is, I always say the devil's in the details, okay? And it's all this junk and compressors and dirt and signs and everything else. You can't find enough of this stuff. I mean, if you see it in a swap meet, you buy it and you keep it. I have literally drawers of them because you can't find the stuff, you know. And some of these people that are casting nowadays can't do a very good job. The metals are not as good as what, you know, George Solios and Bob Van Gelder used to use. Let's see. Okay, that's the inside of that building again. And there's a cat and a dog here. There's the cat right there and a dog here. That's the inside of that waiting station and order station for the trolley line. This is a little tiny structure. It's illuminated. It's got a railroad map on the back of the wall, and it's just, that structure is probably 2 by 3. This is a City Classics building that I cut one of them down and made a little side building to it, put the awning on it, changed the front window assemblies. I have out a little bit of paint and real shingle. No, I say real shingles. These look to be, yeah, those are RS Lasers, a guy up in Oregon. I have him make shingles for me with my requirements. I want them to burn them real good so that you could see that it's got some antiquing already in there. And then I send him the paper that I want him to burn. Okay, this is down a Little Falls, this is Spencer box. Okay, now you got a guy in a 3-wheeler giving a ticket to the guy with the plumbing truck and boiler water heater that's not secured down. You tell stories, you know, that's the fun part of this. A couple little things here. There's a triptych, if you will. 2 motorcycle policemen behind a sign. That's the bus again. And the one on the right is a junkyard. And there is a dog in there, by the way. But I called the guy that makes the cast cars up in Canada. And I said, George, can I get a couple of these just cast, just if they're damaged, fine, all the better. So he sent me about a dozen cars all beat up and, you know, just short shots, if you will, of the resin cars. And I painted them, I cleaned them up where I had to be, and made them look like they're rusty. And there's wheels and doors and everything else. You just go into your scrap bin and find out what you have. I don't know what the guys on the forum, but on our hookup here, this is a, Lou Sassy was out here to photograph my railroad in a couple of years ago. And Lou kept walking around and he'd say, man, you have nice buildings. And he didn't say it once. He didn't say it twice. He must have said it 7 or 8 times. And if Lou, if you're on there, I apologize. I got to have fun with you. So I said, what do you want? He said, would you be willing to make a building? I said, sure. So Dick Elwell is a modeler in New York State. He has in Massachusetts, makes a beautiful layout. If you've ever seen it in magazines, you'll understand. And so Lou wanted this for his. He has an 0-on-30 layout in his house in Carolinas. I made two. I couldn't pass up making one. I had two, one for him and one for me. Now, yes, I've won a few awards, not that it just happens. And then there's the team. The gentleman behind me is my neighbor down the street. I've known him for over 40 years. And I worked on his railroad, which was in the mountains on O scale. And I told him, I said, Russ, when I retire, we're going to change it to HO scale. And he looked at me and I said, we're going to add on to your house. Then he really looked at me. And so anyhow, we did. And he's my electrical guy. I know when I take two pieces of wire and it goes spark, you don't do that. Okay. But he has done all my wiring. He helps me with my switches. And then when he started on his, I did all his track work. Well, you know, I mean, that's the fun of this hobby. You find people that you get along with and, you know, what can I do for you? What can you do for me? It's fun. And then of course, my bride of 40 years, my people painter, and she's outside working in the yard. She's crazy. So anyhow, that's the end of my story, guys. And if you're over, anytime you're over in Arizona, give me a call.
Thank you, Frank. Anybody have any comments or questions for Frank?
Yeah.
It is so beautiful. I would love to come and see it sometime. It is amazing.
Anytime, Trudy.
Oh, I'd love to see it.
As one who has seen it, it is really, really excellent work. I mean, the detail is just amazing. You can spend lots of time just looking at some of the scenes.
And I do run trains. I do run trains.
Yeah. My question is, do you have operation sessions and how often?
No. I find that most people that do operations are all thumbs. And I don't mean that in a negative point of view. I'm just saying I have put too many hours in buildings and other pieces to have some guy go by and go, woof, and all of a sudden take out a chimney or a telephone pole or something like that. I've seen it over here at the Scottsdale Railroad Park. Those guys are always having to fix up when an operation session has occurred.
So then do you run your own operations yourself then? Is that what you
Sure.
do?
Oh yeah. I can give you a controller and you can run with me, but I'm just going to give you a fair advice. Don't put your hand across in front of the green border. Okay. My grandkids are very good about it. I have a lot of people that come by with little kids, and I can tell you, over the years, I don't think I've had but one little minor incident, and it was, minor. So I just warn people politely.
And then, you have a lot of track, which is really nice. So you can really do a lot on that railroad.
Oh yeah.
How do you clean your track?
I have 2 track cleaning cars. And if I don't, got a couple more minutes, Ryan? Gotta just go grab it real quick.
Yeah, a couple minutes. Sounds great.
It's right here, somewhere.
What we used on our O scale, we have a track cleaning car on almost every single train because it runs so much and so often.
Okay.
Oh, so every time. Oh, okay.
I don't know how many people have seen this car before, but this is an old.
Frank, let me take your presentation down so I can put your picture up front here.
All right. Very good.
Okay, that's
there
good.
you go.
Okay, Athearn made this years and years and years ago as a track cleaning car. It's a masonite sled on the bottom. Okay, and I run. I run 2 trains around, and sometimes I'll use them for doing operations. But they always clean the track. And then sometimes I'll do the entire railroad. I'll do all the cars once a year, and that's fun. All my wheels are, there's no KD wheel sets on this railroad at all. They're all the nickel silver ones, Intermountain or whatever. Katie's, that's a cast material that arcs off and it deposits dirt everywhere. The better nickel silver wheel sets are wonderful. I don't get very much dirt at all. So did I answer your question, Mike?
Yeah, I think so. You said that's a masonite sled. So you're saying, wait, can you show that boxcar again?
Yep. You see the masonite piece down here?
Okay.
Does it float on the track?
It's got a couple of little rubber things up on the inside and it just floats on the track.
Oh, lift it up so we can see.
Oh, sorry.
There you go. Yeah.
Okay, so it's floating on the
Yep.
track.
Yep.
Okay, and you can make these. You can make
Yeah.
them.
Yeah.
You just
Yeah.
roll-
Decades ago, I actually made a car with the masonite. I think it was an MR article about doing it.
It's really easy. There's another car that I have. Let me go quickly find that guy. He's right next to me to the ground.
So where do you buy masonite? Is that at the hardware store?
Yep.
Okay.
Yep. Of course, you don't need a very big
Yeah,
piece.
Home Depot, Lowe's, they all sell masonite.
Okay.
And it's the rough side down, not the shiny side.
Okay. Rough side.
Okay. And then this was another car that somebody was making years ago with a, let's see, pull it back a little bit, a T-plug, if you will. And it floats in the hole of this AccuRail boxcar. And it just sits there and it goes around and, does its thing.
Masonite on the bottom too?
Masonite on the bottom. Yes. Yeah. Can you see the color differentiation? Yeah.
Yeah.
Okay. The gray is a cast piece, and then the masonite is just glued to the bottom. But you can take a box car, drill a couple of holes like this one, the Athearn one, and get a piece of 3/16 inches masonite, a couple of nails, and you're done. And run them around, and they really are wonderful. And I'm not trying to bash Katie at all, because I've talked to him about it. There's been several articles years ago, a couple of magazines about the wheels, and I just find that they just are too dirty, That's all. But anyhow, anytime anybody's here, just give me a call. I'm retired.
Frank, are you
And-
back cleaning cars?
And with COVID, I'm in my room. Well, not really. I've had a lot of house projects to do, but it's been a lot of fun. It's very rewarding, and we're doing I think everybody got one, right, Ryan? We sent out that email about doing the a kit. Hang on a second. Well, maybe I didn't send it to the guys in San Diego.
I think that was an Arizona email.
Yes, we're going to, I am holding a Zoom meeting clinic on how to build this kit.
Oh, cool.
So Trudy, if you want, send me an email and I'll take care of you there.
All right.
Okay. We'll get you and Ryan and Pete all to sit in the same room. I did this is a Doug Foscali building, and he makes very nice, simple structures. And I did a clinic building a yard building in San Diego 2 times back, I guess, whatever. And I had about 8 or 9 people in the meeting, and it was fun. It was the funniest experience was one guy came in with his wife. I don't know whether Bob's on here or not. And he said, "Do you mind if my wife sits in while I build this building?" And I said, "Yes, I do mind." And he looks at me like, "What?" And I said, "I have an extra kit. She's going to build it. Between you and me, woodshed, she did a better job." But that's okay. It's fun, and I love building these things. Some of these builders take shortcuts, and I've learned from all the different manufacturers some of the things you should do and shouldn't do. So we're going to build these. So if you want one, Trudy, send me an email. I'm going to order them on Monday, so let me know. Rest of you guys, well, I'm sorry.
Maybe we can get him to do it again sometime too.
Oh yeah, that's not a problem. Yeah.
Anything else for Frank before we move on to our clinic?
You make it too easy.
Frank, thank you. That was a great layout tour.
Oh, thank you.
Really love your layout and you know, the guys, how many of you guys can go as quickly as Frank did and lay your hands on a specific piece of rolling stock? Seriously, that was impressive. Because I can't do that. You know, which cabinet's it in? Where is it? Yeah.
Oh, no. Yeah, but I ran the trains yesterday for a young man here in town. And so I knew where they were. They weren't too far away. I actually was going to have a steam train running behind me while we opened it up, but I didn't have enough time.
Still, you remembered from yesterday till today where you put it. That's a great accomplishment.
You've been talking to my wife?
Not recently, but.
And he's also a fast learner. He opened up his PowerPoint much faster the second time.
Yes,
and he was
thank
faster
you.
the third time. So
Thank
this
you.
is today. So he's doing great.
Thank you very much.
Commercial for television.
All right. So Tim, are you ready? Tim?
Yes, I'm ready.
Okay, Tim is our layout tour chair here in San Diego, and he has a layout in his garage that he's been working on that's awesome. But he's going to teach us about electricity.
Ooh.
You got it. You're up.
Okay. I had a funnier initial picture, but I started getting paranoid about copyright issues. So, so you get this one. Now this is aimed, mostly at beginners. Hopefully towards the end, we may have some time if some of the more experienced model railroaders want to make any suggestions. I'd be glad to hear from them. Okay, this gets a little scientific. Bear with me on it. It's important to know about just a little bit of physics. It's just basic physics involving voltage, current, resistance, and power. Voltage, the best comparison for voltage is to water pressure. Electrical current is equivalent to the flow rate, and the resistance is similar to the pipe size. Those are three measures of electricity. Current is measured in amps, resistance is measured in ohms. Direct current is a constant voltage, as is shown in the example on the right. And AC voltage is a variable voltage going from positive to negative. 1 volt is the pressure required to force the current of 1 ampere through the resistance of 1 ohm. And I have a very important diagram to show that to you in the next slide. These guys on the left. And basically, a lot of people think of voltage, they confuse voltage and current. Voltage is just the pressure on the electricity. Current, as measured in amps, is the flow of electricity. And the guy at the top, he is you can change the amount of resistance to slow down electricity and to change the amount of volts that is going through the pipeline. So you can almost regarding resistance, you can almost visualize it using a multimeter on the ohm setting. You can put the probes in a glass of water, and you will get a resistance measurement on your multimeter. That's a multimeter. I assume everybody is familiar with a multimeter. If you're a model railroader and you don't have a multimeter, don't tell anyone. And maybe go out and get one. The multimeter pushes a small amount of electricity from one probe to the other, making a circuit through the water. because your body is primarily water, you can do the same thing holding the probe in each hand. The ohms are the quantity of resistance that slows down the electrical flow. Okay, now we're getting real deep. This is about as serious as this whole presentation gets. So you know, don't run away right now. But I had to kind of dive into this serious stuff just to orient you. You won't be tested on any of this, so don't worry about it. And it takes a while for all this to soak in. There are some excellent videos on YouTube if you want to dive into this a little more. Basic videos by electronic experts. I happen to be an attorney, and we have an electronic expert in the club who owns Tam Valley, if you're familiar with that. And I asked him to do this presentation, and he refused to do it because he's used to teaching graduate school electronics students. So maybe it's better that I do it. I don't know, because I'm just I just know some of the basics. You can use algebra to determine the correct resistor size for an LED circuit. This is a common project that we deal with, is our LEDs on our layouts. And this is a diagram of a LED. The squiggly line here is resistance, and then this is the light emitting diode. The arrows imply that it's a light, that it puts out light. And if you don't understand diodes are basically a one-way valve. If you want to go back to the water analogy, if you took the battery, this is the battery source here, if you took that and flipped it and ran positive this way backwards, you would get no light, because it's a diode, and a diode only permits electricity to go through one direction. I'm sure there's theories that will contradict that position, but generally that's the truth. And then now we get to Ohm's law. The current is equal to the voltage divided by the resistance, or current. They for some reason they express current with an I, or amps equals volts divided by resistance, and that's Ohm's law. And that's important, so that if you're going to install a LED in a new DCC engine that you have, or you're upgrading a DC engine and you want to get rid of the incandescent lights, it helps to know how many, what kind of resistance you need. You need what size resistor you're going to use, and so that's the next equation, which is just the flip of the Ohm's law. And that is resistance equals volts divided by current. And here's an example. If you had 1200 ohms, that would equal 12 volts divided by 10 amps or 10 milliamps. And that's with the assumption that the LED uses up 10, it's not 10, it's 10 thousandths of an amp. Sorry about that, 10 milliamps. That the LED uses that much current. Some of these things you kind of need to know in advance. With these equations, you only need to know two of these items to come up with a third solution. And if you get, and here's two other variations of the same formula to get voltage and then there's a different formula to get power. And power is expressed in watts, and power is volts times current, or amps, which is pretty simple. You might be able to memorize that one. And that is important later when you're using power supplies and that sort of thing. Okay, so forget all those formulas and go onto your store on your cell phone and download an app that will calculate all this for you. And this is an Ohm's law calculator. What I threw in here is I knew the volts. That's, you know, my power, my power was going to be 12 volts, which is standard power in a decoder. And then I knew that the diode used 10 milliamps, and so that gives me 1200 ohms and 0.12 watts. Let's see here. And you don't always need the exact, you don't have to go out to the store. If you have a 1,000 watt or 1,000 ohm resistor, you don't need to go to the store to get a 1,200 ohm resistor. You probably can get by with a 1,000 ohm resistor. You can, this stuff, there's a fudge factor on all of this. And then I have a note that the power rating is 12 watts. A 1/8 watt resistor can handle that power, but I would pick a 1/4 watt resistor to avoid any issues with the heat. And I'll get to that little issue. That's kind of an important issue, because if you put a resistor that's too weak into your new DCC setup on your engine, it can get hot. It can get very hot, and that can create issues, which you don't want with an expensive DCC decoder. Okay, this is another area that's important, are wall warts. And let's start by looking at the label on this. This was a charger that I had for a marine radio, actually. But you can use this. You can use most of these wall warts. You can use them on your layout, and you just have to adjust them using resistors, etc. So this one says the input is you have 120 volt, which is standard current, wall current, and it gives you a wattage here, 7 watts, and that gives you kind of an idea. That's similar to 7-watt bulb. And then the output is 10 volts and 120 milliamps. Well, I hooked this thing up. I plugged this in the wall, hooked it up to my multimeter, and found out that all of that was wrong. That it's putting out, the one I have puts out completely different measurements of voltage and current. So DC layout transformers are often an impractical electrical source unless you can use the AC leads. Wall warts, I'm talking about a regular layout transformer, because it's variable. You want a steady power. So that's why wall warts are so much better. And I'm talking about powering your switch machines and your lighting primarily here, and any animation that you may do as well on your layout. And you have to note that wall warts, they have wall warts that have AC output as well, and usually you can't use those. Though there are some animation projects that you buy that will permit use of DC or AC. I happen to have one. So you want to carefully look at the specs on your wall wart. If the output voltage exceeds that you need, then you can step it down with a resistor, which is always the case with LEDs. Okay, when you cut the connector off the wall wart, you need to determine the polarity of the wires. Usually it has some kind of an input, a metal connector, and I just cut those off and put some crimped terminals on it. But if you forget the polarity, it's easy to figure that out. You just plug it in and hook it up to your voltmeter, and you can figure out which side is positive and which side is negative.
Is it okay if we ask a question, Ryan?
Yeah, if you want a question, go ahead.
If I don't ask now, I'll forget at the end.
All right.
Sorry. So this is really great. These wall warts, they all have different specs, like some will put out 9 volts and some will put out 15, etc.
Yes.
Do you kind of standardize
I just collect stuff that say come off of, on a portable phone, and there's a lot. I just collect them.
Do you try
I
to
don't buy too many of them.
you use them? Do you try to standardize the outputs? That is, say, you know what, they all put out these various voltages, but I'm going to put the resistors in at the where the wall wart is. I'll put the resistor right in there to always make it 12 volts or something like that from all of them. Or do you just string?
It depends on what you're going to do. If you're lighting, if it's for lighting, you can get by with with 5 volts. Most LEDs use 3 volts or less. But if you're going to light a whole bunch of them, you can light a whole bunch of them with 1 wall wart.
Okay.
And so you need a little bit of current going there to light a group of LEDs. And I'm going to get to calculating the current in a second. I hope
I just thought it might be easier to standardize all the wires coming from these wall warts to different places by having them all kind of the same values coming to wherever you're going or something like that. I don't know.
Well, if you're going to buy them directly, you can do that. That's fine. And another thing I use when I wire my layout, I have a label maker, and I use those labels religiously. If you look under my layout, there's all these wires, and I'm not too picky about how I do my wiring. It looks like a spaghetti pretty much, but I do have a lot of labels on everything. So if you labeled everything carefully and you had different specs on each of your wall warts, you still will know what's going on if you label them.
Okay, and a final dumb question. If you need 12 volts, can you use a 10 volt wall wart and somehow use resistors to get the voltage higher?
No, resistors do the opposite. Resistors constrict the current.
Yeah, there's no way to bump up. You can't bump up the voltage.
No.
You can only bump it down.
No, you can't. Yeah.
Thank you very much.
Okay. Good questions. Okay, when I checked this wall wart out with my multimeter, it showed 12. It was putting out, even though it says 10, it was putting out 12 volts. And also on a multimeter, there's an amp setting on many of the newer multimeters. You get an amp. You can get an amp setting, usually up to 10 amps. If you go over 10 amps, you might burn out your multimeter, so you have to be careful about that. And through my amp test, I found out that it was 1.1 amps, which is way over what they say. They say it's 120 milliamps, and I came out with 1,100 milliamps.
Right, but they're not saying the short circuit. Sorry, Tim.
No, go ahead.
They're not saying the short circuit current is 120 milliamps. They're saying if you pull 120 milliamps from that, you'll be at, they guarantee you won't be below 10 volts. When you put your ammeter on it, that's like 0 ohms. So you're measuring the short circuit current. Anyhow, sorry for interrupting.
Okay, no, that's a good point. I didn't completely understand it though. What do you mean?
Okay, so this device is, the label says, I'll put out 10 volts when you pull 120 milliamps. This is a very poorly or unregulated device. So as you noticed, when you don't pull any current out, it's putting out 12 volts or something higher. If you start to pull more than 120 milliamps from it, the output will just sag until with your ammeter, when you put 0 ohms across it, you are short circuiting it. Now you're measuring what maximum current it could possibly put out into a short circuit. And that's what you measured with your meter when you saw it was an amp. Okay.
So you're saying if you use the full current, if you use the 220 milliamps, it'll produce that. But if you use more current than that, you're kind of, it doesn't guarantee that it will produce that.
Right, you're loading it down. So this
You load
isn't
it down.
right. Now, if you had a better regulated power supply, some wall warts have really good regulators in them, or a bench type supply, it will put out the rated voltage over a wide range of current. So if it says I'm good for 5 amps or whatever, you can go anywhere from 0 to 5 and expect that that rated voltage, 12 volts or whatever, is going to hold nice and steady. This device isn't quite in that caliber. But when you short any of these out with your 0 ohm ammeter, right, across it, either it's going to have a short circuit protection circuit and it'll stop putting out current altogether, like your DCC command station might do if you shorted it, or you'll just pull whatever its maximum current is and start heating the thing up inside. And so think of putting a 0 ohm resistor across the output when you put your ammeter directly across it.
Okay.
Yeah,
So
if you would have had 2 voltmeters or 2 meters and one measuring that 1.1 amps and another one to measure the voltage at the same time, you probably only had about 2 out of that thing.
You'll have like 0 volts because the ohms of your ammeter on the 10 amp range are very low.
So if I calculate a resistor, what is it? R equals B over I or something. Come up with a value of 10 over 120. Get a resistor like that, wire it into a little, and then use that with my meter. Could I then see these values properly?
I don't know. I don't understand.
Okay, so
Robin
it sounds
might
like with no resistance, you get these weird readings. So that means to me, if you put in resistance, you get readings that are more in line with the numbers I see here. Is that true? Or am I way off base?
I'm not
Oh,
sure.
you're absolutely right.
What's that?
Okay, so
Yes, that's a correct statement. If you put a resistor value that would pull 120 milliamps at 10 volts, then yes, that would be what you would measure most
and
likely.
that value would, and I bet if I got the math right, it's R equals 10 over 120 or something like that would be the resistor I'd use.
That's correct.
Okay, thanks.
All right, I'm going to move forward. I'm going to move on here. Okay, and then there's another concept here that I skipped above. When you're trying to figure out what size resistor to use, like for example with LEDs, and that's forward voltage. Oh, by the way, I don't know if you've already read this, but it is important that say we go with a 120 milliamp capability of this wall wart. You don't have to use all that. You only have to use whatever the device that you're lighting, like an LED, needs. There's no need to use up all the current capability of a wall wart. It just sits there and dispenses whatever the device needs. You don't need to. Nothing's going to happen if you're under the current capability of the wall wart. The forward voltage is the amount of voltage needed to get current to flow across a diode. And most common LEDs require a forward operating voltage of between 1.2 to 3.6 volts. I was looking around recently because there was a question on the NMRA site about 1.5 volts, and I had trouble finding diodes that use less than 2.1 volts. But maybe they exist. I don't know. I got these figures off the internet, and I'm not sure that 1.2 figure is right. Anyhow, so you have a forward current rating of about 10 to 30, and most of them have use up 10 to 30 milliamps. So wall wart might accommodate this wall wart using the specs as read, or might accommodate 110, I guess, using the amps that I came up with, would accommodate 110 LEDs lit at the same time. And you have to be careful about that. You don't want to have more draw than your wall wart can handle, or you can have problems. You could burn out your wall wart and you could maybe start a fire. I'm not sure. You always want to stay under, you want to calculate. So if you're using a whole bunch, if you're using one wall wart to light a whole bunch of LEDs, you want to do an estimate of how much power those LEDs altogether are going to use if they're all going to be lit at the same time. And you want to make sure that wall wart can handle them all. Otherwise, you might want to use 2 wall warts. You might want to split it down. You can, and again, you can use the current draw of the LED using the amp setting on a multimeter, or use the estimates. Note that if you push less current through an LED than its rating, it won't light. And that's what I meant about this 1.2. I don't think you'll get any LEDs to light at 1.2 volts. Here's a diagram of an LED. The one on the left is a standard LED that we're all familiar with, that comes encapsulated in a clear resin. And then the one on the right is a surface mount light emitting diode. And they come, you can get those in very small sizes, which is an advantage. And as I mentioned before, they're diodes, so they're unidirectional. And they sell LEDs, and I use a lot of them on my layout for my my directional lights on the layout. And they're called bipolar diodes, and they'll put out 2 different colors. The most useful being red and green. And all you do is they look, the ones that I have, they have 3, they sell 3 lead bidirectional diodes, but they also sell 2 lead bidirectional diodes. And all you got to do is set up a switch that flips the polarity on these 2 leads. I don't know if you can see my arrow. And then that'll give you a different color. Okay. And then an easy way to test an LED is using a hearing aid battery, because they've only put out 3 volts. They're not going to burn your LED out. 3 volts normally will not burn out an LED. Maybe it's possible, but so that's an easy way to make sure your LED's working. And then always note the flat side of the lens is the cathode, the negative side. You got polarity is critical with LEDs, because if you get it the opposite way around, you're not going to hurt anything, but nothing's going to light up. You always have to have the proper polarity, and so the negative side is the flat side. And sometimes the length of the lead is what is it? Yeah, the cathode lead is usually the short lead. The negative lead is the short one. And now we're into resistors. Here's a diagram of a resistor. It's a thin metal film resistor. These are the standard resistors we use on most of our trains. And you wanna, like, if you're setting up LEDs for an engine, if you're setting up your headlights and your rear lights on an engine, you need a separate resistor for each lead. And on a decoder, there are the controlling leads are separate wires. It's a blue lead that's your common, which is positive, and the others, the other leads are that go to the decoder are negative. And for each negative that's connected to a light, you want a separate resistor. You don't want to try to save money, and resistors, by the way, cost practically nothing. You want a separate resistor for each one. Let's see here. Okay. I solder the resistor directly to the LED lead, first wrapping the bare wire around it. I follow up with a piece of shrink tubing. You got to use shrink tubing religiously on this. You don't want to put everything back together and then watch your and have a short and watch your decoder fry as it, you know, your $120 decoder fry as it starts to run down your train track. It doesn't matter. You could, if you use, like for example, with a decoder, if you use the, if you used only one light at a time, you could get away with one resistor on the blue lead, on the blue positive lead. It doesn't matter which side you put the resistor on, but you might have situations where you use more than one light at a time, and so for that reason, it's always wiser to use put the resistor on the negative leads, which I think are yellow and white is usually what they have. This is a diagram of a SMD resistor, a surface mount resistor. And it's, you need to be able to identify your resistors. Sometimes you get them mixed up. It's good to keep, when you buy them, keep them in the same package and make sure there's, you know, you identify the number of ohms for each resistor. This is, for an SMD, there's usually a number on it, and that's an ohms indicator. And then for the other resistors, the thin metal resistors, you can get a chart like this, and based on the bands on it, you can figure out how many ohms that is. Now, I highly recommend getting a breadboard. There's a place in town in San Diego here called Willie's Electronics. They have one up in Kearny Mesa. I've never been to that one. And there's another, the original one is down in National City. And they have all this stuff you need. They specialize in things mostly for people who do sound equipment on cars and that sort of thing. But they have a lot of useful things for model railroaders. And then you can also buy all this stuff online, of course, too. But what you want to do, just for your own satisfaction and knowledge, is if you're going to install some LEDs in your engine, you want to test it all on a breadboard. And one of the important things you're going to test for is the resistor. And as I mentioned earlier, if here I usually use a 9-volt battery, but even with a 9-volt battery, if I don't have sufficient resistance, or if this resistor isn't of the right capacity, if it's a 1/8 watt resistor, it's possible that it'll get hot. And you can put your finger on it, it won't hurt you. You just tap it with your finger to see if it gets hot. And it's good, you know, test out your, you know, play around with your LEDs with a breadboard. It's very helpful and useful to kind of see what happens. This is a little anecdote. I saw a guy on YouTube burn out an MRC decoder. He had a video, he's real proud of it. He burned out an MRC. He wanted to show that MRC decoders weren't any good. And you know, they're not everybody's favorite decoder, but they work. And he installed an LED on it without a resistor. Well, he burned out the decoder, and he didn't really learn anything or show us anything by doing it, except that he didn't understand that he had to have a resistor for that LED, or else he'd burn out the decoder. Some decoders have internal resistors, and you need to look at the specs, and a lot of times you don't get the specs when you buy the decoder. You don't get all the specs. You need to go on the manufacturer's website, and they'll all have plenty of information what that decoder contains. But most are 12 volts, so you're working from 12 volts. If you add a resistor decoder that has an internal resistor, it won't do any harm that you added a second resistor to it, but you might not get the LED to light because you have too much resistance then. you can usually estimate what you need for a particular light. A lot of people use 1,000 ohm resistor for the 12 volt for a 12 volt lead coming out of the decoder for one LED light. But that may not satisfy you. You want to test. Another important reason to test it on a breadboard is that it'll give you an idea, and then you want to do it with a 12 volt wall wart instead of using the 9 volt battery, and that'll give you an idea of the brightness of the light, if that's important to you. So that's another advantage of testing everything with a breadboard before you put it all together and put it on your engine, so you don't have to pop it all out and redo everything. I think I've talked about a lot of this already. Okay. To be fully accurate, you should use a forward voltage amount to determine the resistor size. The resistor size equals the battery voltage minus the LED voltage over the desired LED current. So for a typical white LED that requires a 10 milliamp powered by 12 volt, the values are 12 volt minus, you're subtracting the forward voltage, the voltage that the LED is using in your calculation here, over the amps, which equals 860 ohms. To use several LEDs in parallel, sum the amp values and insert it into the equation. And then eventually you'll be able to estimate this stuff in your head instead of having to do all this, but it helps to go through all these steps first. And then putting the electronics to use. These are signal lights that I built. I used some parts. The target shell is from Oregon Rail Supply, which is a great place. You buy a whole bunch of these for a low price. Instead of paying 30 bucks a piece for these, you can build these for, less than $5 a piece. And then the wiring I got at, I happened on this wiring, and they call it, what do they call it? A wrapping wire at Fry's, and it has, it's very, very small wiring that's sufficient for these searchlights, but they also have insulation on them. When you buy searchlights from like Tomar, they use a lacquer for the insulation. For some reason that bothers me a little bit, but they do work all right. The lacquer is kind of difficult to work with though. Instead of plastic insulation like these, they just paint a lacquer over bare wires. And then the lamp is connected to to a crossover switch wire that moves the tortoise switch control. And I connect it in series with those wires. So when I flip, I have switches, and I'll show you a picture of them in a minute. Crossover switches. There's a diagram on the instructions for a tortoise switch, how to set up these crossover switches, and then I have the bipolar diodes, LEDs in these lights, and so when you flip the switch, it flips the polarity and changes the color of the light, and it also moves the switch at the same time. And I just connect, everything's on about 9 volts, and they're all connected together, and I have resistors going out to the diodes, of course. This is a picture of some crossover switches. They're not that hard to put together. And then this is the diagram out of the tortoise instructions that show you how to do these crossover switches. And then on a tortoise switch machine, they also give you, and I don't always use these. There are when I had the 3-prong, I had a few 3-prong bipolar diodes. I needed to use these internal switches that come with the tortoise switch machine, And you can use them for other things. You can use them to power the frog as well. That's initially what they're meant for. I don't power my frogs. Or you can use it for other lighting purposes, like an indicator light by the switch out on the fascia of your railroad. I'm not going to go into all those details. This is the outcome here. These are some of the lights here. I don't use block control, so I just use the switches as indicators of which way the switch has turned. Now we go into animation projects. This is over here on the left is a crossing signal flasher. And the key thing to a signal flasher is you want one side to light. A crossing signal usually has two lights on it. And you want one side to light while the other one dims out, and then vice versa, go back and forth, back and forth. And that's the key function of this flasher. And I bought this thing used at a swap meeting. It just showed up in a box I had, and I wasn't sure it worked. So the way I figured out that it did work was to hook it all up. I've got two diodes here, and I hooked it all up on the breadboard and found out that it worked. So I got all excited. I actually bought something that works. And then this is a optical optical detector that for block occupancy, to tell you that in a certain block of your trains, there is a if you have like an under table route that you can't see all the time, you could use a block detector. Well, it'd be a problem. You'd have to have light under there, but you can use a block detector to tell you where your train is. That's another project you can do with electricity that's important. Now you can use this for other purposes, like for crossing, as a switch for your crossing, railroad crossing lights and that sort of thing. Or you can use it for, if you have a sound module, if when your train comes by, it could set off your sound module and you have sound coming out, that sort of thing. And each circuit has its own sensitivity control. Those are these two potentiometers here, these little blue things down here. And then this is a more complicated animation circuit detector module from Greenstein Products that I bought. And then now we go to relays. Relays are important. Ryan, am I way over time?
Probably,
Ryan.
yeah, try to wrap up like in the next 5 or 10 minutes.
Okay, okay. And relays can be helpful. I used some relays on the 3-prong signals I had, LED signals that I had. I had to break over to a relay. This is like a physical relay here, and this is a circuit, integrated circuit type relay here. And I'm not going to go into the details of that. I'm going to move on. And then these are sensors. And what there's two types. There's what do they call these? Cadmium sulfide photosensors. You have photosensors, and then you have infrared sensors as well. And the photosensors, and these are all useful, like to set off these would connect to some of those boards I showed you earlier. And so if the train comes by, it could set off a railroad crossing signal, or it could set off a sound module or whatever you want. So it's good to get to know sensors. I'm kind of short on time. I'm not going to get into the details of them. The infrared ones are a little more popular than the photo sensors, but I kind of like the photo sensors. If you want to turn off your lights and show and do night lighting and running your railroad, the photo sensors won't work in the dark, but the infrared ones will. And you can get more information on that on the internet. This is a little device I hooked up. Just more examples of using electronics with your railroad. And this is a speed sensor, a speed detector that will give you a real railroad speed. It's a speedometer. It'll give you a real railroad speed for your train going by. And I set mine all up. It works fine. This is who makes this thing? TCS makes this, and it's excellent. I got it at I forget the name of the place now. In Arizona, actually. And then if you really want to go crazy with electronics, you can get an Arduino, which is a logic board that will that you can do all kinds of different projects with. There was an excellent in our last convention. Pete got a guy. I think that guy might have been from Arizona to give us a training on Arduinos, and he did an excellent job. And there's a ton of information about this, and there are model railroad groups too, so you can get pertinent information for model railroading about using the Arduino. The same goes for a Raspberry Pi. A Raspberry Pi is a computer, basically, and they don't cost very much. They're under $50, and some guys will load up a DCC system on this computer, this little mini computer. It's not very big, and a JMRI on it as well. And there's guys online that show you how to do that, and they'll let you. You can download software for this Raspberry Pi from those guys, all set up to set up a DCC or JMRI. This is tips on wiring your layout. I have a boat, and I rewired my entire boat. And I'm old fashioned, so I stuck with the same system for my layout as well. And I use these terminal connectors, these terminal blocks to connect things. They're very handy, and I use crimp connectors for that. And if you have to troubleshoot something, which I haven't had to do, I kind of work slowly and methodically. I only had to troubleshoot one thing on my entire layout. These make it a little bit easier. You can have access to things a little quicker with these terminal blocks. And you just have to remember to label everything carefully. This is more stuff. These are, if you're gonna set up a DCC layout, it's fairly large, you wanna set it into power districts. And I have 3 power districts on my layout. And what that does is if you have a short somewhere, you can isolate it right away to your power district, to one of the 3 power districts. So you're not looking through the entire layout to worry about the short. And that helps. And these are breaker switches that I have and from DCC Specialties. This over here is a automatic reverser as well. Lots of electronic stuff. And Ryan, if you want, I can stop right now. This is kind of heavy stuff about DCC that I got from DCC Wiki to try to understand DCC. But I don't think we have enough time for the rest of that.
That's probably a good idea, because that's
okay.
It's a deep topic in itself. But thank you so much. Any questions or comments for Tim today?
Yeah, hey Tim, good job on that. So I'm actually, my career is in electronics, and one of the problems we always have is people who know a lot about this stuff trying to explain it to people who don't know a lot about it. But I think you did a great job with that. So yeah.
Thank you. Who's talking?
Chris Thompson from Arizona.
Oh, okay. Thank you, Chris.
Sure.
Hey, this is Steve Seidensticker. I got a question for somebody out there. I've got a problem with anyway, I've got a problem. I want to hook up a light on the back end of a tender, and I don't know whether the light that exists in there is an LED or an incandescent bulb. Is there any way that I can just put an ohm meter or any sort of multimeter set to something and figure out whether it's an incandescent bulb or an LED?
Yes.
Yes.
So if you set your meter to ohm setting to do a resistance, if it's a light bulb, you can measure the resistance and flip your leads around and measure it again. If it's the same both directions, it's a light bulb. If it's significantly different in one direction from the other, then it's an LED.
Ah, thank you, thank you, thank you.
Sure.
Yeah, LED is a diode. The power is only going to go one direction.
I'm going to do a mute all just to get rid of the background noise, but if there's more comments or questions, just unmute yourself.
So Tim, one other comment. You're talking about the diodes and the different voltages required. So that's based on the formula that they manufacture the diode with, and I've seen them operate as low as on 2.2 volts and all the way up to the 3 volts, like you say. So it depends on the manufacturer and what they're doing with it, and the formula they use to make the diode.
I've got a little device here I wanted to share. This is a little LED tester. You can get them for about $5 on eBay, and what it does, it basically will tell you whether your LED works. It'll show you which is the positive and negative, because if you have it backwards, it just doesn't work. I use a lot of LEDs and lighting and installs and stuff. In fact, last night I was just going through doing some little surface mount resistors on LEDs, and I'm using a 680 ohm resistor, and I buy my LEDs clear, and I dip them in Tamiya clear orange, which gives you a really nice incandescent headlight type effect. I buy the warm whites, and I usually buy them in 100 3mm size. I buy about 100 pieces at a time out of China, and they last me for a long time, and I can give them away. Anyway, that's my comment. But a really good clinic. I enjoyed that. A lot of good stuff in there. Are we gonna have that published somewhere so we can go back and look at it?
Well, it'll be on the YouTube video online on YouTube, and we can think about a way to share the PowerPoint.
Yeah, you could probably put it on your website somehow for the division.
Peter, what was
We'll
the name
talk
of
to our
that ohm meter again? I meant LED tester.
Oh, just go on eBay and just Google LED tester. They're all the same, but they're a bunch of different brand names. They're about $5. If you can get one that's here in the U.S. already, you might have to pay a little bit more, but you won't have to wait forever to get it from China, because shipping from China really sucks right now. Anyway, FYI.
All right. Any other questions or comments for Tim before we work on wrapping up?
Can you vary the brightness of the LEDs by having greater resistance or something like that? If the LED is a little too bright, can you tone it down?
Oh yeah, definitely. Okay. Yeah, that's really neat about this tester is you can put it has different milliamp ratings on it, so you can tell. I just settled on a 680 ohm resistor for all of my headlights in HO scale, and it seems to work fine. That way I don't have to calculate each time.
Okay, thanks.
Can you hear me? I have a question for Chris.
Yes, we hear you.
Yep,
Oh,
go
okay.
ahead.
On that 1.2 LED, volt LED, would that be a surface mount, I assume?
No, that's some of those were older versions that was used in mil spec hardware. So, you know, they were trying to get maximum brightness out of those things. So that was part of it. Plus, it was older and the technology isn't as great as it is these days.
Oh, okay.
Hey, I just wanted to say one thing. I'm new to electronics, so I found a free course online, and they recommended to buy like an electronics kit. It comes with these little wires and breadboards, a bag of LEDs. It has a bunch of resistors. It has a whole bunch of other things. I don't know what they're called, diodes and things. So Tim, I just want to let you know, I'll be calling you pretty soon for help.
We'll get Chris's phone number for you. Chris or Robin.
Or Pete.
You're gonna, all of a sudden your phone's gonna be ringing off the hook. Hey, it's Mike again.
Yeah.
Yeah, one selection or suggestion on electronics, if you want to learn things.
Yeah.
There are thousands of videos out on YouTube where they go through detailed circuits and things like that on how to use resistors, LEDs, Arduino things, and it's a lot of them are very, very good.
Thank you.
I don't want to cut anybody off, but what I'm going to do is I'm going to kind of wrap us up a little bit, and then I'm going to turn off our YouTube stream, and then we can continue to chat or leave or whatever people would like to do. Hang on a second here. All right. So thank you everybody for coming and for participating in our event today. And I really like all the input and the conversation that we were able to do. It was a lot of fun. So I thank you for Frank. Thank you to Tim and Trudy and Mike for sharing. And those of you on here, please next time, somebody else, some more people volunteer for show and tell, so we can have a little variety there at the beginning, because I know everybody has really cool stuff they're working on. And we can learn a lot from each other. I will do it again next month, and you'll see our events on the website. And remember the Facebook page, and this will be up on the YouTube channel. And I think that's it. So I'm going to wrap this up in case see if anybody has anything else wants to say.